So now we're going to solve some more inequalities. They're going to be maybe a little harder this time, maybe more steps to them. So on this side there's nothing we can do, so we write 6 plus 2y less than or equal to. Over here we can distribute. We get 2y minus 4. Remember, taking the 2 times everything inside the parentheses. Here it gets a little tricky because we're distributing a negative 3. So negative 3 times negative 2 would be plus 6. And then negative 3 times negative y would be plus 3y. So watch your signs. Now if you notice, we have several things we can put together on this side. I have a 2y, but I also have a plus 3y. Remember, that sign in front goes with it. So that would be 5y. I have a negative 4 plus 6. So the signs are different. I'm going to subtract. I get plus 2y. Now we need to get the y's on one side. I'm choosing to subtract 2y. You could do something different here. Leaves me 6 less than or equal to 3y plus 2. Since I did bring my y's to the right, I need to get rid of the 2 because I'm trying to get my y by itself. It gives me 4 is less than or equal to 3y. So I would divide by 3, and I do get a fraction. Just leave it a fraction. 4/3 is less than or equal to y, which means y is greater than or equal to 4/3. So that would be my answer. Again, we need to distribute on this one, so we got to distribute on both sides. We're going to get 2x plus 8 is greater than, we're distributing the negative 2, so that would be negative 2x, but be very careful here. Negative 2 times negative 5 would be plus 10. Here I'm distributing a 4, so it would just be 4x. 4 times negative 2 would be minus 8. Again, let's see if we can simplify. That'll make it a lot easier for us if we do that. We got a negative 2x and a 4x, so we can put those two together, and that would be positive 2x. I also have a 10 minus 8, that would be a positive 2. So now let's subtract 2x from each side. And 2x minus 2x is 0, so that's gone. So we have 8 is greater than 2. So when the variable disappears, you need to ask yourself about that statement. Is 8 greater than 2? Yes, that's a true statement. So that tells me my solution is all numbers will be work for this. All numbers is what the variable can be, any number you want it to be. Alright, on this one we got decimals, so we still should be able to work with decimals. When you get to the last step, I don't have a problem with using a calculator, so we're going to subtract 1.2x from each side to get my x's together. So this would be 1.3x minus 4.7, and you have to line up your decimal there, equals, don't want an equal sign, less than 5.7. So we brought our x's to the left, so that means we need to get our numbers to the right, so we need to add 4.7 to each side. Again, you must line up your decimal point. Get 1.3x is less than, carry your 1, 10.4, you bring your decimal straight down. So now we need to divide by 1.3, and this is where you use your calculators to do the division. You're going to get x is less than 8. Okay, this time after we solve it, we need to graph it. So it's a pretty basic one. We need to get x's together. If I want to keep my x's positive, I'm going to subtract 3x. You could choose to do something else, remember. I get negative 9 is greater than 2x minus 7. So since I brought my variable to the right, I need to get rid of the 7 over here with it. So I'm going to add 7. Signs are different, so I subtract. I get negative 2 is greater than 2x. Divide by 2. And get negative 1 is greater than x. But when I read it from the x, it's really x is less than negative 1. So to graph this, I'm going to put negative 1 in the middle. I have a 0 here and a negative 2 over here. Negative 1 is not less than negative 1, so it's an open circle. That means negative 1 is not a solution. All numbers less than negative 1 are going that way. So that would be my answer to that after I graph it. Again, a word problem, so define your variable. This time it says find all sets of 2 consecutive positive even integers. So x needs to be my first, and what am I looking for? Must be positive, must be even, and it must be an integer. So all of that needs to go in your definition. To find the second one, it would be x plus 2, because even integers are 2 apart, equals the second positive even integer. Says their sum, so the first one is x, plus the second one is x plus 2. It says it's no greater than 16. If it can't be greater than 16, it would have to be less than or equal to 16. So now we go about solving it. We get 2x plus 2 is less than or equal to 16 when I simplify. Subtract 2. I get 2x is less than or equal to 14. Divide by 2. We get x is less than or equal to 7. So it has to fit this, but it also has to fit my definition up here. So I need to find a positive even integer less than or equal to 7. So what's the largest positive even integer less than or equal to 7? If you think about it a while, you should come up with 6. So x is 6, then what's x plus 2? 8. So that would be one pair. What other positive even integers do we have that are less than or equal to 7? We have 4. 4 plus 2 is 6. And 2. 2 plus 4 is 4. Can we use 0? No, because it is not positive. So that's why we would be finished with that.